recording. All right, so welcome to the lecture today. As I said, first thing we would like to do today is to make up the groups or the teams for the project assignment so that we could start the next days with the project. I think that Professor Kohlhase will start also this week, and I think she has also started a little bit with the roles. So to do so, as I said, I would like to have groups that are kind of diverse and also equally balanced regarding the skills. In particular, experience with software development, which of course is some kind of where the skills probably are different and which might affect the group performance. So I think it's important to have different skill levels here and to create the groups somehow equally balanced. And this time I would like to do this by some more automatic mechanism. So nobody can complain afterwards, hopefully. And I have some exercise, or well, not an exercise, but something to do for you. And that's in Moodle. Let me share my screen. If you look at the Moodle course, at our Moodle course, here, I now enable this selection here. And this is basically like a kind of survey for everyone who wants to participate in the project exam, project assignment, which is part of the exam. So I would like to ask you all to briefly fill this out. The basic is that so if you look on that, you see that you you could make choices, and I hope it's now available for everyone. I made my choice already, so please make a choice. And basically, I'm just asking you for your gender, for your kind of skill, if you have experience or not much experience. So it's up to you what you fill out here. But of course, try to judge yourself somehow critically. And please briefly register there and fill it out so I then can use this data to create some groups. How many responses do we have? Yeah. That's great. It fills up. Wonderful.
Excuse me, Professor.
Yes.
So the survey only asks my gender and if I'm an international student or not. It
Yes.
does not ask what kind of experience do I have.
Yeah, but there should be an item called experience development, experience developer, yes or no. If you feel you are experienced or not, that's all.
Okay.
I could only fill out the gender as well.
There is no option for experience developer.
Yeah, I mistakenly filled out like 2-3 boxes, I guess. Can I reset it?
No. We really can't reset it. I was assuming that you are able to do it in one run. But we can change that. Obviously, it's difficult to fill out 3 boxes. Yes. Let me see settings, how we do it. So now you should be able to edit your choice as well.
Yeah, thank you.
Okay, so if you have completed that, the main goal was that I will export that to create the groups, and yes, so that's yeah, that's the idea for that purpose. And we can so we can I can do that by downloading the responses. Stop the sharing here. And stop it. And yes, and now I've written a program that converts this to a tool. And that will help to create the groups then. But let me do that when we do the exercise, so we do not waste time. Thank you, at least for giving the information. So we now can create, or I can create some groups for you for the project, which we will then, I will show you the process later on. And okay, then the next thing now would be to complete the work that we started last time, I think, which was about the modeling of use cases. And no, it's wrong. And last time I think we started to work on the use case descriptions as well. Let me check. Yeah, we have. Submissions here. Okay, so I think we should at least discuss these. Yes, I think that was what we want to start today with. Okay, so I share my screen and we will, let's say, have a short presentation by some group. For example, this is a example use description. I think it was group number 5 or something. It was uploaded by Patrick Wagner. Could you please present your result, or someone of the group?
Yes, I can present it.
Yes, please.
We decided to do the print bill use case.
Yes. Mm-hmm.
Yeah, to describe it in short, it's a use case that the service personnel selects items that should be billed,
Mm-hmm.
and in this use case, the corresponding bill to these items is printed out. we identified the service personnel and also the customer as actors in this use case. And as a relation, we identified the service personnel in a direct relation to the customer. And for the input data we need for this use case, we identified as a kind of a trigger the customer that says he wants to pay and want the bill. And in this case, the service personnel selects the items and the bill is created. So as I said, as a result, the bill is delivered and can be handed out to the customer, and then the customer is able to pay the bill. And the workflow could look like described in the last step. So the personnel select the meals to create a bill. They click a button with the name Create Bill. The system shows all this pre-processed bill on the screen. The personnel can check this bill, do some adjustments, and if there's nothing to change, the bill can be delivered to the customer if the print button is pressed.
Okay, thank you. Well, already very good. So first of all, what you see here is this is a typical way to do it in a kind of a table, which is a good way to describe use cases. And then in the workflow, I would make the suggestion to, well, the workflow starts with an action by the service personnel. But to select something must be on the screen. So I think the system needs to show some kind of main menu before or something. So you can press Create Bill then.
Okay.
Yeah, so the first thing is missing. So you start with, or you define that as a prerequisite, that all use cases start with main menu displayed or something, but it should be clear where you start. And then, or what the system does first. And then, and then system shows pre-processed bill on the screen, and you can accept it or do some adjustments, and then deliver the bill. What does it mean? Is it printed, or what is it? So I think something's missing here. You deliver the bill. So if the service presses the print button, okay. So service presses the print button.
We thought the bill is printed out and then handed to the customer.
But then I would say press print button, system prints the bill, service delivers it, or hands it over to the customer, something like that.
Okay.
So that's clear what the system needs, what the order of the action is. So it's just a press button, pressed, printed, and then. And then customer pays the bill. Here we could add some details. What kind of payment offerings are provided? Is there an external payment provider, something like that? So how is payment handled? Is it in the same device, or is it just the payment is confirmed somehow and is done with cash, or I mean, there are many
card or credit card.
Or is it card only? Then you have a card reader. Is the card reader directly connected to the handheld of the service personnel, or that should be specified in more detail, I would say. But beside that, it's fine. So the overall structure is good. All right. Let's see another one, maybe. Okay, that's good because it's another remove delivered meals from the screen, and it's also a little bit of another format, which is fine. So could someone explain a little bit in this group?
I think I uploaded it.
Yes, okay.
So it's the use case remove delivered meals from the video screen. And the user selects the cooked meal from the list on the mobile device and then removes it from the list. It's done by the service personnel, and it's only related to the service personnel. So the customer himself does not have to do anything with it. As a precondition, the meal must be cooked and the customer must have received the meal. And then the result of the use case is the meal is removed from the list of the meals.
Okay.
And yeah, the workflow is we have a display a list of cooked meals on the mobile device. The users or the service personnel selects the cooked meal that has been delivered to the customer. And then there's like a sub menu for the meal that has been delivered. And yeah, the user can select the quantity of the delivered meals. For example, if a customer wanted the same meal twice, the service personnel can enter the number of the delivered meals, and then you click the meal delivered button. You see a confirmation screen. You accept the delivery confirmation, and then the user is taken back to the main menu of cooked meals to the list.
Yes. Okay. Yeah. So yeah, that's good. So it already starts with display list of cooked meals. So it starts with a system action, so the user can do something. That's good. First of all, what you see here is an approach to describe the use case not in terms of a table, but more like a structured bullet point list, which is fine, perfectly fine. It could be done like that. So it's up to you in your project documentation that you hand in at the end. You will have to do this use cases for your system, but it's up to you how you structure it and represent it. This is perfectly okay as well. So what I wanted to point out, so this description here is much more precise. It has more steps and it's more system and user, system user. Nevertheless, this is still to some extent, it does not cover all possible navigation cases because, for example, here it says system shows delivery confirmation screen. User accepts delivery. What happens if the user doesn't accept? Is there an exit? Can he cancel the screen somehow and go back or whatever? So this is not described here, which is okay for the first draft. But what you see is if you want to really model all possible navigation flows through the screens, this probably will get rather complex very soon. So it's not so easy to do that in text form. And this is why it might be helpful to kind of support or augment this workflow description in the use case description by something more graphical, let's say, like, for example, a wireframe navigation flow or some kind of process diagram, something like that, which could be added here to illustrate it or make it more precise when text becomes too complicated. For example, you could think of an activity diagram or kind of a process flow or something to make this navigation flow more explicit. Yeah, so that's just a recommendation that I just want to tell you. So this is a kind of the first version of a use case. It's perfectly fine. But then, of course, you could think about all the details and add something here as well. So it's not uncommon that use case descriptions for each use case get much more sophisticated and detailed and longer in practice. So I've seen use case descriptions which were multiple pages long in detail with text and diagrams and so on. So it's not necessarily just short as this. But of course, this is a good starting. All right, thank you for that. And the next step now is that we think about the next step in modeling, which is or one possible next step. So let's assume you have your system, you have done the use cases, you have done the use case descriptions. All these things would have been reviewed and negotiated and at least agreed upon with your customer. Okay, so this is a typical work that business analysts do in projects, that they kind of capture the requirements, describe them in use cases, and so on. So now we have, so let's say, a set of use cases that are settled. The next step now would be to look more on the data structures involved and the business objects that we actually are considering. And that is something that has a relation to the use cases. So if you start to think about modeling your structures, which in particular would be modeling or using what we call the class diagram of UML. Alternatively, we could use the entity relationship diagram, which is more or less semantically similar to the UML class diagram, with the exception that the UML class diagram is more powerful and contains more details. And therefore, it should be preferred usually, because it makes things more precise. And yeah, so the class diagram is what we want to do next. And in the videos, there's this introduction to object-oriented modeling as well, I think, which explains the class diagram. So let's have a look. And in particular, let's have a look on the relations between use cases and classes. And for that, I would try to switch to the whiteboard again. Let me switch to the whiteboard. So the typical thing is, now you have use cases, and now you think, okay, how can we move forward? Okay, how can we move to the next step? At the end, we want to build a software. So what will we learn from the use case diagram for building the software? And one important thing that you could derive from use case diagrams is at least some class candidates. So possible classes. Let's see that. So let's try to sketch a use case diagram. Like that. So we have some box for the system, and we have some nice ellipses. So let's say we have a use case order meal, and we have some nice little actor. This is just an example. Okay, it's not the full diagram. I'm just trying to. Do we have some figurine here? Yes. But arrow. Okay, so that's our use case, and the actor is, for example, the service person. Okay, it's unfortunately not very big here, but anyway, so that's our use case. So if we now think about, we have this use case diagram, what would be our class model? Well, then it's rather easy to think about, okay, what would be potential classes that we have in our functional problem, in our domain, in our system? And the potential classes that we have, so the classes describing the objects we would have to manage to handle in our system would be, well, it would be the substance, the subject of this use case names. So in this case, order, and it would be the actors. Yeah? So we would have then classes like service person, could be a waiter or whatever. We would have a class called maybe like order. We would have a class meal. We would have a class payment, whatever. So these things that occur in the use case diagram. Of course, when we critically think about that, we might realize that we do not need all these things as classes in our class model, because they might be more like implicit entities or something like that. But it does not. That's not the. So it's not a one-to-one thing. It's not a hard rule that you say every actor, every subject in this, every noun in the use case name is a class. But every noun, every actor in the use case is possibly a class. So it's kind of a candidate. And of course, if you really model it, if you really have to add it to the class diagram, you as an analyst, as an architect, you have to think critically about that. But this is the starting point. So you look at the use case diagram, and if it's done properly, you will find most of your business entities, so the objects that the system is working with, as well as the actors, the roles that have to be somehow modeled in the system in your use case diagram. And then you could use this to do the actual class diagram. So it's not that a use case diagram is kind of something that's not related to programming or to the code or whatever. It's the first step in the analysis, and it leads to the classes. Okay. So class diagram. Let's have a look at the class diagram. Let's have a look at the class diagram. So this is kind of a short preview to, it will be, I think, in the video of the next chapter as well. So where is it? My class diagram. Here. So I will give you this this slide then in the next slide deck. Anyway, let me briefly explain that. So what we want to do now is modeling a class diagram. And a class diagram is similar to the use case diagram. It's a diagram that is part of the UML, so it's contained in the UML, and it's a typical thing that's related to object-oriented modeling. So UML is a language or a formal way of doing object-oriented analysis and design. That's the actual purpose. And for the design part, also for the analysis and the design, I would say the class diagram, beside the use case diagram, is probably the most important diagram. So we cover it here. And yeah, the class diagram is not so complicated, but it of course has in detail a lot of power and a lot of things that need to be discussed. So the class diagram basically consists of classes and their relations. And the relations are modeling the, as the name says, the relation between the classes, or better, the relation between the objects of this class. And if you have seen the introductory part, this short video lecture on Java and OOP, which I have provided, the difference between objects and classes is explained, and so we can assume that this is clear, and this was also part of the prerequisite to study here. So you have to have Java and OOP and so on. So a class diagram contains classes. Classes are boxes, basically, or displayed or illustrated by boxes, as you can see here, these nice boxes. And these boxes then inside, the first thing a box has a name. So this is the class name. So we have a class cheese platter and a class cheese and a class mouse and so on. A class, just to remind you, is the kind of blueprint or description of a set of objects. So it describes a set of objects, and this set of objects, or each of these objects, then belongs to that class. And these objects are described by two things, namely methods and the operations, or the methods, which are the operations, and the attributes, which describe the properties of the class and therefore of its objects. And here you can see that, for example, for cheese, we could have the fat content, so the percentage of fat, the milk type, is it a raw milk, whatever. So we can have multiple things. For the cheese splatter, we might have the size and the color and whatever. So these are the properties that an object of this class would have. And yeah, so then we have the relations between these classes. These relations are, there are different types of relations: the association, the aggregation, the composition, and the specialization. And in the classical entity relationship diagram, which you might know, typically it's kind of introduced in database courses in the beginning. This classical entity relationship diagram, which dates back to the 70s, it was introduced by Peter Chen in 1976. The entity relationship diagram is a predecessor to the UML class diagram. So it is not something different. It's basically the same thing. It just has less properties, or it's not as powerful. It does not express all the aspects in detail. But otherwise, it's the same thing. So an entity is basically the same thing as a class, and the relation that the ER diagram has are similar to some extent to those that you can model in the class diagram. And yeah, so the basic relation that two classes could have in the class diagram is the association. The association is kind of the most general way of a relation. And if you don't know what type of relation is, it's typically an association. So it's kind of the generic case. An association means that the objects of two classes are in an association with each other, and that each object belongs or is related to a set of objects of the other side. And that is described, the association, first of all, is described by a straight line. You connect the two classes with a line, and then the first thing you add are the so-called multiplicities or cardinalities, which are these numbers that you put here. And these numbers indicate that, for example, in this case, the numbers on the opposite side, they indicate how many objects of this side are related to how many objects of that side. So it says, if there's a star here, which is kind of the n, then it means multiple. So the star in UML says it's one mouse is related to an arbitrary number of cheese. Vice versa, every cheese belongs to exactly one mouse. In this case, okay, so every cheese belongs to a mouse, and one mouse has multiple cheeses. So this is a 1-to-n relation. In UML, you say it's one on this side, and you say, for example, it's a star on the other side, and you can add so-called roles, which are describing. So this means cheese belongs to mouse, something like that. So this is a textual description that you add to the line. So this is the association. And each association has a name. So this association expresses that this cheese is owned by this mouse. It owns relation. We then have two specializations of the association to make it more precise. And the reason that they are introduced is that this is a typical and very specific case, namely the case that one object contains objects of the other class. And if you have this contains relation, then we speak of an aggregation. This means that an object of one class is contained in an object of the other class. We have that here. So the cheese platter contains the cheese. So this means that every cheese could be on 0 or 1 cheese platter. It could be also a no cheese platter if it's just flying around somewhere. But it could be on one cheese platter at maximum. It cannot be on 2 cheese platters logically, because either it's there or there. And vice versa, cheese platter can have an arbitrary number of cheese from 0 to infinity, more or less. And the aggregation is modeled by this square, and the aggregation is expressed by the empty square, so the white square. And the square is always on the side of the what we call the aggregate, so the class that describes the object that contains the others. So it's not the one that's contained, but the one that contains the others. So in this case, the cheese platter, that's the aggregate, because it's made up of the objects of the other class, aggregates these together. And then we have the last kind of even more special thing is the composition. The composition means that the composition is an aggregation. So if you don't have an aggregation, you will never have a composition. So it also means that the objects of one class are contained in the other class, but it also means that the lifetime of the objects of the contained objects is identical to the aggregate, so that they are undivisible. So an object of the composition, if you have a composition, it means that the objects are the same lifetime. So they are created together and they are deleted together. And you cannot exchange them. So they cannot take out an object and move it to another object. Then you would have an aggregation. And that's the actual thing is it's very, very difficult to find examples for composition in the physical world, because you can nearly divide everything into parts. It's more a concept that appears in abstract concepts. So this cheese and whole, this was very hard to think about. I found at least this, I think it's a good example. But so a cheese contains holes. A Swiss cheese contains holes. And you cannot, in fact, you cannot take out the holes, and the holes are created. If the cheese is made, the holes just appear. And if you eat the cheese or melt it, the holes disappear. Okay, so you cannot have the cheese without the holes, and the holes cannot exist without the cheese. Okay, and that's important. And then you can speak of a composition, but it's very hard to, we call that an existence dependency. So they are kind of linked, undivided, they're undividable. You cannot tear them apart. But in physical world, it's difficult to have an example like that. But in the logical or in the abstract world, it's easier. Let's think of, for example, you can have a position of a bill. So a bill or an invoice contains positions. These are an essential part of it, for example. That could be a composition, but not in the physical world. Okay, so that's just an example. So what I want to say when you model things, there seems to be, in my long time experience as a lecturer, I have made the experience that students love composition. I don't know why, but they love composition. They always try to, there must be a kind of a strange force that forces you to fill out the rectangle to make a composition. So it's the same as the aggregation, but it's a filled rectangle. So I don't know why, but they always do compositions, and in 90% of the cases they are not really good. So they are basically wrong, or at least questionable. So I would really say, every time, this is a general remark, every time in your group, in your mind, something says this is a composition, stop. Think about it. And think about it if it's really a composition. Okay, sometimes it is, but it's not so easy. And you should not overuse that. So in most cases, it's just an aggregation. And if something in your hand is kind of making you shiver, and you have the feeling you now need to fill out this rectangle, stop. Okay? You're probably on the wrong way. Sometimes it is a composition. But as I said, it's not so easy to find good examples. Why this is special? Because in programming it has some consequences. So it would mean that you, for example, create the sub objects together with the outer object, and that you, for example, have kind of the mechanisms to delete them also synchronously. You could do that in a database. You could, but it requires some logic. Okay, so that's the reason why it's kind of there's a separate way to mark it. And then the last thing that is, of course, an important relation, very important and very typical for object orientation, is the specialization, or sometimes in Java we would call it inheritance, or we extend the class, for example, in Java. So this is the relation that describes the inheritance. It means that the Swiss cheese is a special type of cheese in this example. So you draw a line, and it has this arrow has this special target, or this special rectangle and on top. So it's a closed rectangle, and it says so that's the official symbol, and it says that this Swiss cheese is a specialization of cheese, which means that it inherits everything from the cheese. So it has all the attributes and the methods from the cheese as well, even if you don't have to separately describe them here. So a Swiss cheese is a cheese. It's not something different. It's not another class, but it's a special version of the class. And this is specialization. And this, of course, makes it different from the association, because it does not relate objects of different classes, but it is kind of an extension of the we call it the parent class. So this is a parent, this is a child class. That extends something to this parent class. So, and this leads to the famous Liskov substitution principle. Every object of a subclass must be usable as an object of the parent class, always, because it is a special object of the parent class. Okay, so that's a concept, yeah, and I think some of you probably are familiar with that already. So we now could start to try to practice. And of course, the goal is now we do groups again, and you have the task to draw the class diagram for our burger restaurant, as far as we know it already. So we have some classes, orders, menu, whatever, and we can model it. So let me create the breakout rooms again. All right, so let's do 10 breakout sessions, and now, so we have 40 minutes to go, and let's say half an hour, and you sketch. So the task is each group should discuss and try to draw the class diagram of the burger restaurant application. Fred's Burger Restaurant. Okay, so use what you have in your use cases and try to draw the class diagram. First, in the first step, don't talk too much about, so omit the methods. They are not so important in the moment. First of all, concentrate what are the classes and what are their relations. You might then think about some attributes for the classes, but I would not talk about the methods at this point, because we're not in too much technical detail. So focus on the classes and the relations. I think that's the most important thing. And we can start now. We have, let's say, good half an hour. And I'll send you to the room before. Again, of course, the question is that, is the instruction clear? Does everybody know what to do? It seems yes. So if questions, please ask. And okay, before you ask later, I will switch on the screen sharing. always the problem. And now I start and open the rooms, and you will be moved to the rooms now. All right. So what I said is I would like to conclude with some remarks. First of all, as I already said, so please upload your class diagrams here in this upload option if you have not done so far. And second, I want to create the groups for the project assignment. So this is part of the exam. And as I said, I would like to create the groups in a diverse way. So we have mixed groups with internationals, with German students, male and female, people with more and less experience and so on. So the goal, of course, is that you learn to work with each other. That's important. And then very often, of course, we have a group exercise. So group exercises always have some risk that in the group you have people who might not work so much or are not reachable and things like that. So those of you who have experience with practical group exercises during your studies already will probably know that this happens. And usually then at some point the students start complaining why I have this group and they are not working, whatever. So let me emphasize that among the learning goals or the learning objectives of this module, of this course, is not only to learn software programming, modeling, things like that, so the technical skills, but it's also about the non-technical or non-functional skills, which means that you should learn, or let's say interpersonal skills. So you should learn to work in a diverse team where you manage or try to learn to work with people with different mindsets and different backgrounds and so on, different cultures. So that's the goal. And if you have the feeling that the group is not performing well, this is the challenge for you, and this is part of the learning goal. So this is not an extra kind of obstacle for you, but it is part of what you should do in this course, because we are an international program. So let me just give you that as a motivation and of course the results of the group will be the better the more the team works as a team. We had experiences that the team split into sub-teams, not talking to each other, doing strange things. And at the end, the result for all of you will be bad because the things do not fit together. So that could be a risk. So please try to communicate and practice agile practices, which we learn or which you might have seen in the video as well. So that is also important to learn to work in these kind of team contexts. Okay, and this is the reason why I do the teams now and not let you choose your teams yourself. Okay, so that's the goal, and to make it very clear and to make it very objective and without any doubt, I have chosen an app which is kind of doing some random choice. You see this wonderful hat, so we will do drawing from the hat like a wizard in the circus, and so that will be electronically. So I have imported your list that you made during the Moodle in the beginning, and I think that with 10 teams we will reach a reasonable team structure. Not too big teams and so on, because many students, but I think with 10 teams we can cope. So now we will do the kind of drawing of the teams from the hat, and everyone is a witness. It's like in a lottery or something. Okay, so let's do it. And I have some conditions. So I have this thing supports trying to equally balance skills and gender and so on. So that is here, which is configured just to make sure. So I said balance team strength, balance male, female, equal ability teams, and sub-teams enabled because I need the international feature as a sub-team. Okay, so let's try and see what happens. Yes, and it says that it's not possible to, because the subteam international is so big, it splits it equally. So now we have reached some nice little teams, 10 teams, and I will, as you can see, hopefully the teams are mixed between German and international students as far as possible, and also between male and female and so on. Okay, let me paste that to Moodle. And I will add that in the Moodle course. Here in the general stuff. Chat. Okay, it's not. Yeah, but you can download it and look at it. So it should be that. For all of you, can you please check if you can see it and everyone finds him or herself again in this list?
Professor, I think I'm not in the list.
Yes. Then did you did not fill out the survey in the beginning? That could be. Yeah, but as I said, so the teams are not of equal size. So we have this one which is a bit bigger and this one as well. So if someone is missing now, you could join one of the smaller teams. Okay, you could join, for example, team 10 or something.
Okay, thanks.
Yeah, please join team 10 and contact the others that they. So what I would recommend you to do now, I would really recommend you to set up kind of a communication channel for the teams. So each team has some channel they can reach each other, like for example, a WhatsApp group or a Discord channel or whatever you want. Yeah. I would also to kind of recommend to establish meetings regularly, probably online, because some of them are not here already. And you will get the kind of the task to do in the next days. This team is for the whole module. So it's for the assignment. Assignment is a combined assignment between Mrs. Kohlhase and myself, okay? So it's one exam and one project, okay? So what you do there already is part of the overall thing, and you will do it in these groups. Okay, any questions? So the goal is that we will then establish in the next days or next week then a kind of an agile project model, so that we will define some sprints and some artifacts to deliver after each sprint and so on. And yeah, so
Hello,
Yeah.
Professor.
Question? Yes.
I think my name is not is there in any team.
Okay, so you then go to team 9.
Okay, thank you.
Good. All right, so that was, I think, the most important thing for today, that we create the teams. No, of course, the most important thing is what you learn, but team creation is also important. And yeah, that's, let me check if you can read it, if this is visible here in the course.
Can the last person who just said he's going to join Team 9 just send his name into the group, please?
Yes, please send your name.
Sure.
Yeah, in the chat probably, and just for team 9, so the team 9 can add it. Wonderful. All right, so I think that's so if there are no more questions, then let's stop at that point. I will stop the recording.